Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over a couple of practice problems involving Hess's law. And so in a previous video I had talked about three relationships that involve the delta H of a reaction as well as the equation, the balance equation that comes with that delta H of reaction, or the enthalpy or heat of reaction. The first one was if you multiply the equation by a certain factor, then you multiply the delta H of the reaction for that same reaction by that same by the same factor. The second relationship is if you reverse the reaction, then you have to take the opposite sign of the delta H of the reaction. So if the regular equation is a positive delta H, if you reverse the reaction, then you make it negative. The magnitude will stay the same. And the third one, which is also known as Hess's law, says that if the overall reaction can be seen or expressed as the sum of several steps, smaller reactions that could be added together, then the delta H of that overall reaction can be found by adding those delta H's of those reactions that are steps to the overall reaction. And so I'm going to basically do a couple of problems where all of those are involved together. So the first problem I want to talk about is this problem here. This problem is asking us to find the delta H, or the enthalpy of the reaction for this reaction here. So here we're given three different reactions or equations, and the goal is to see if we can manipulate these and add them together so we can get this one as a resultant of these three. So we'll have to do some manipulation. So if this is the equation we want, and we want to add these together to get this one, then we got to look at what we have here. So we'll notice here that we have C3H8, which is our propane gas. This is as a product, but here we have it as a reactant. So we want to make this a product. In order to do that, we're going to have to reverse this reaction. So we're going to have to make it go the opposite way. So we're going to have to make this 3CO2 gas plus 4H2O gas, and then that's going to go to C3H8 gas plus 5O2 gas. So, and then if we reverse this reaction, remember we have to take the opposite sign of the delta H. So the delta H of this one is going to be the positive. So that's going to be positive 2043 kilojoules. All right, so now we have our C3H8, our propane, as a product, which is what we want. Now we see that carbon here is a reactant, and we have carbon here as a reactant, but we don't want one carbon, we want three carbons. So in order to get the three carbons, we're going to have to multiply our equation by 3. So if we multiply this equation by 3, right, we're going to have to multiply this whole thing by 3. So 1 times 3 is 3, 1 times 3 is 3, 1 times 3 is 3. So that becomes 3. But again, if we multiply the equation by 3, we must also multiply the delta H by 3 as well. Okay. So we can kind of get rid of this one since we don't need that anymore. So we have this one now. We have this C3, so we have C3 here. And then the next thing is we want to look at, we have 2 H2 gas, we have 4 H2 gas there. So in this case, we want 4 here, so we're going to have to multiply this equation by 2 to get the 4. So if we multiply by 2, we'll get 4 H2 there, which will be what we want for the reactants. We'll have to multiply that by 2, and then we'll have to multiply this by 2, and we'll get 4 waters. So now Now that we have what we want here, we just need to make sure that everything cancels out when we add this together. So all three of these, when you add them together, should hopefully add up to that one. Let's cross out everything that is a reactant and product that is the same. So here we have 3O2, right? And we have 2O2 here. So we have 3 and 2, that's 5. And we have 5 over here. So these two are going to cancel out with that one, since we have 5O2 as a reactant or as a product, and we have 5 as a reactant. So that's going to cancel out. The other thing is we have 3O2 here, or CO2, and we have 3CO2 as a product. So we can get rid of those as well. And the last thing is we have 4 waters here as a product and 4 waters here as a reactant. So we can get rid of those. Those will cancel out. And then everything else is what we're left with. So we have 3C solid plus 4H2 gas is going to give us the C3H8 gas. So these three equations will add up to our target equation. So which means that if these three add up to this one, then the sums of these three are going to add up to the delta H of this reactant here. So then all we need to do is do our calculation. So we're going to take 3 times negative 393.5 equals, and we're going to add to that negative 483.6 equals, and then we're going to add to that 2043 kilojoules, and that's going to equal, and our answer is that this is going to give our delta H is equal to a positive 378.9 kilojoules, because we are adding, or we have to pay attention to the least number of decimal places, which is 0 decimal places. So then we must have 379 kilojoules, rounding the 8 to 9. So that would be the delta H of the reaction for this reaction here. So we use the 3 principle, we use Hess's law of adding these together to figure out what the delta H of our given reaction is that our target was. Okay? So that's the first problem. The second problem is very much like it. So again, here we're given a different equation. This is our target. We want to know what the delta H, or the enthalpy or heat of reaction, is for this equation here. They give us 3 equations to work with, so our goal is to find a way to add these together to that one. So we're gonna have to manipulate these again. But we have those 3 relationships. So once again, I have NO as a reactant, but here I have it as a product. So I'm going to have to switch this around. So I have NO here, and then I'm going to have to reverse it. So I have 2 NO2 gas is going to go to 2 NO gas plus oxygen gas. Okay. The middle one also has NO as a gas, or as a product. Notice I have 2 here, but I need 3 as a product. So I have 2 NO as a product. This is already a product. So now I have 4. But I don't want 4, I want 3. So what I'm going to have to do is I'm going to have to divide this by a half. So I'm going to multiply by a half so I can reduce this by 1. So if I multiply this, this will be 1/2. So N2 is going to be 1/2. And O2 is going to be 1/2. Okay, and then this one would be a half as well. That would be one way to do it. The other way to do it would be if I go another route, that stays there. So I've used this one already. I'm not going to use that again, so I'm going to get rid of this. And the delta H for this one, before I forget, is going to be a positive 113.1 kilojoules. Okay, so now I have this one. I have this one here, and I have 2NO, and I have 2NO. So instead of multiplying this by half, I could divide this by half, which would be useful as well. So if I divide this by half, then this goes to 1, this goes to 1, and then this goes to 1/2. So I have a half of oxygen gas. But then again, also I have to multiply this by a half as well. So now I have, if I add these together, I have 2N, where is it? So I have 2NO gas here, and I have 1NO, so that's going to add to 3, and that's going to give me my 3NO gas here. I have 1N2O gas on the reactant side, and I have 2 N2O gases here. So what I could do here, if I want just 1 N2, I would multiply this equation by 1/2. And so I don't need to switch it around because N2O is a reactant, and so that's where I want it. I have it as a reactant. So what I can do is I can multiply this equation by 1/2. So 2 divided by 2 gives me 1. 2 divided by 2 gives me 1. And I get 1/2 oxygen there. Okay, so now I have 1/2 oxygen. So now I have my 1N2O, 1N2O. And now I need 1NO2. And I have, where's my 1NO2? I have 1NO2 here. Okay, great. So now I have everything I need. Now I need to add them together. I'm going to cancel out anything that I have on both sides. So I have N2 gas here as a reactant. I have it here as a product, so I can get rid of those. Those are going to cancel out. I have 1/2 O2, 1/2 O2 oxygen on the product side. I have 1 on the reactant side. So the 2 halves are 1. So the 2 halves are going to cancel out with the 1 oxygen on that side. And let's see, I have, I think that's it. So when I add these together, I get N2O gas plus NO2 gas is going to give me 3NO gas. And so that is the equation that we are shooting for, N2O gas, NO2 gas plus 3NO gas. And so with that, I have the target equation. So now all I need to do is add these together. And when I add them together, I get, so it's going to be, so 182.6 plus negative 163.2, and that's going to be 113. Hold on a second. Times 113.1 divided by 2 equals, and I get 9,000 and 46.36 joules